Okay, so you bought this massive hardware system or multiple hardware systems, and you're trying to manage files across many different ones. At some point, it becomes kind of ridiculous to try and think about tracking files across hard drives with like a spreadsheet or just knowledge or labels or however you do that. At some point, you want to turn over some of this management to a piece of software. And that's just when it comes to managing files. There's lots of reasons why we don't want to manage this hardware directly, that we want software to manage it in order to perform functions that computers are just far better at performing than we are as humans. So, what are we talking about there? Well, it's helpful to go back to this archival storage diagram and think about some of these functions that we're looking at. So we're receiving data and we're providing data. Okay, I can hook up a hard drive, I can put data onto a hard drive, I can pull data from it. That doesn't seem that fancy. But error checking, managing storage hierarchy, replacing media, disaster recovery, those are higher level, more complicated functions that we might want software for. And the biggest thing is that error checking thing. A big part of our business goal is to say we're not losing stuff over time. I'm not going to say we never want to lose data. We know we might lose data, but part of our goal is to reduce the possibility of that. Okay, so there's lots of ways that we could lose data. And I'm going to go from rarest to least rare here. Rarest is the bit flip. This is the thing that you hear people talk about the most. Bit rot, bit flips. The fact that like you stored a file and you come back one day and just a single bit is different, and now you can no longer open the file. It's corrupted. The data's gone. Things like that. These, in all honesty, don't happen all that often. They happen from causes like cosmic rays, a very energetic particle coming in from somewhere in the universe and hitting a hard drive at exactly the right point and flipping that bit, perhaps hitting it while it's in the wire so that we don't even know that it happened. Yeah, it doesn't happen all that often, but it is a nice oh boy, this stuff can happen even under the best of circumstances. It's a little bit like, finding a worm or an insect has eaten a page or a hole into a page in a book. It shouldn't happen, and a lot of the processes that we put into place make sure that don't happen nowadays, but it's still the thing that we focus on quite often. More common is things like equipment breakdowns. This is an image of a hard drive where the armature has actually fallen onto the platter and scratched it up real good. That platter should be a nice smooth mirror-like surface. You can see it no longer is because it's been scratched, and all that data is now gone. It's very, very hard to recover that data. Most likely, the particles that were magnetized have been moved around, and it no longer has the pattern that we would need in order to read any of the bytes off of it. So this is more common than something like a single bit flip, and you're losing a lot of files if this happens. You might also run into software errors. You might run into, and very commonly we run into this, and when you're moving files from one medium to another, that potentially whatever process that you had, skips some files or changes those files or does something to those files during that transfer. And so even though you think you're copying things and everything's fine, if you compare the source and the destination, there are some major differences. And then you go, oh no, what did I lose and how do I recover from this? So just because software is there doesn't mean it's always doing the job we think it's doing. It's something we need to check in on. You could have natural disasters. This is far more common. This is a Photoshop version of a data center flooded. All of these drives might be recoverable, but it's probably a pretty bad time for whoever has to come back and fix this problem. Again, much more common. Things like floods, things like global warming are causing us to think about this even more so. Could have malicious staff. This is an image of Sandy Berger, a former national security advisor to Bill Clinton, who was convicted of stealing documents from the National Archives and Records Administration. I don't have a case of somebody doing that with digital files yet, but I would not be surprised if that is happening. People, if they have access, they might have reason to either delete or corrupt files within your collection, especially political ones. That's a very, very common use case for this. You also have staff accidents, which I'm going to say is probably one of the most common things. I've heard stories from all types of organizations where files have been lost in large part because somebody had access to, back-end access to the storage system and accidentally pressed delete, and okay, file's gone. Or they said, oh, that image file it's good, but it's too big for me to put on the website, so I'll open it up in Photoshop and I'll resize it and make a JPEG, and then I'll press save, and okay, file looks good, and oh, that was actually the archival copy. And so now we accidentally just overwrote that file and the original TIFF is gone. So lots of ways that staff accidents happen, and something we need to be wary of that, is probably more likely for somebody to lose a hard drive and to lose all the files on it than it is for, that hard drive to just break down spontaneously. So how do we take care of these things? That's what that error checking process is all about. It's the fact that when we put things onto storage, we need processes to make sure that those things are stable. And in large part, we do that because we are trying to store things in duplicate at the very least. We are storing copies of things so that if we notice that something is wrong, we can go back to another copy of that file on another storage system and replace it with a good copy. So this is a diagram of that type of a process, that you have a file, you have a monitoring process by which you check the fixity of that file over time. That's part of the reason why we generate fixity information, because if at some point in the future we notice that the checksum of that file is off, we go and we check another copy of that file and we say, is the checksum for this one good? Great. Get rid of this bad file and replace it with a good one. So, we can do all those types of things. We can respond to cosmic rays. We can respond to equipment breakdowns, software errors. All these things have a nice little fixity check issue with them that you can monitor for them over time. I will say one of the scariest ways that you can lose your content is from your budget. And I use this as a scenario posited by a very large cloud provider who says, we provide you a 99.999999% guarantee that we will never lose a file. And we know that there is a far higher probability that you will lose your files. And you will lose your files because you will stop paying us. And here is our 1 in a million chance of something that is very likely to occur. And I will tell you, it has happened to me. So you're buying storage from this cloud provider and you change your credit card. You change your credit card, therefore the credit card that the cloud provider has on file doesn't work anymore. And when they try to charge you for the next month of service, they say, I don't know, it didn't work. So they send you an email. And when you get that email, your email inbox says, this looks like spam, or you're like, I don't want to deal with this right now, and you ignore those emails. And so they're like, okay, well, didn't respond to email, maybe we'll give them a call. And when they call you, you get a phone call, and you're like, I don't recognize this phone number. You don't answer that phone. And at a certain point, that company says, we've tried really hard to make sure that you didn't fall off the face of the earth, and you're not responding, so we're going to kill your account, and we're going to drop all your data. And I've had this happen to websites that I've run. And, they're just small hobby things, but definitely didn't feel that great when I realized 7 months after the fact that they tried every method possible to contact me, and I just hadn't responded. And it was entirely my fault that all that data got deleted. So something to keep in mind about this, and we're going to talk about that in the next portion of this lecture. But for now, let's talk about technical ways that we can address these storage losses. So first thing, as I mentioned, we store multiple copies. Especially in archival storage, you want at least 2 copies, potentially 3, and some people go even more than that when it comes to their collections. We want media diversity. We want multiple types of hardware so that a single type of hardware doesn't blow up in our face and we lose it all because of a bad production run or something. We want geographic redundancy. So, if Hurricane Sandy hits New York City, it's very good if we have a copy of our data outside of the New York City metropolitan area, because that makes sure that that copy is outside of that danger zone. We do fixed monitoring. Over time, we don't just trust that our storage system is good. We test it and we repeatedly go back and say, are the files all still there? Do they look the same as the last time we checked, as the time that we put them in there to start with? We also put in security controls. We don't give people back-end access. We make sure we have an audit log of what's happening. And hopefully we just have lots of money. This is the lifeblood of the system, so money's always going to factor into it. All right, so how does each of those work? Multiple copies. If you ever lose content, the only way to get to recover from that is to have another copy of that content and to pull back from there. In IT language, they'll talk about backups or disaster recovery or things like that, but we're just going to talk about copies because these aren't in any way preferential to one another, any copy of a file. All of these files are good files until we find out one is broken, and then we'll take a good file and replace it. So at least in my architecture, I don't have a primary copy and a backup copy. I just have two copies. So how do we do this? We can do things like take our local storage and put a copy of it on the cloud, or when we put things into our system, always make sure that we're putting them onto two devices immediately during the ingest process. The problem is, as time builds up, as changes accrue, how do you make sure that those different storage systems stay in sync? So if you're thinking about that first scenario, putting local storage to the cloud, how often do you run a sync process because you're working on the local version to push it up to the cloud? Is it possible that the cloud provider is going to charge you to do that? It's something that you have to consider. Also, 2 copies I said is good. 3 copies is what that Library of Congress advice says. Some people go even more, but every one of those copies is going to be a multiplier on how much you're spending on storage. If you're spending $1 million for 1 copy, you're spending $2 million for 2 copies. And it starts to get harder and harder to justify more and more copies. So you have to figure out, okay, what do I want to do here? Media diversity. So this is another thing that I've seen in my career. Potentially, if you buy all into a single system, you start running into problems where there is a production defect in that system, or that manufacturer goes out of business, or you have an incompatibility with a new system that you buy, and you have to do a lot of workarounds to work with other things. So, how do you get more diversity? Well, number one, you buy media from multiple different manufacturers that you say very specifically, we are going to go to 2 different companies to build our storage system. Copy 1 is going to be on this one, and copy 2 is going to be on that one. You do things like going to the cloud, and you say, okay, well, I have my on-site storage system, and then I also have a cloud storage system, and that gives me some media diversity. You go to multiple cloud vendors, lots of ways there, but whatever you do, the challenges here are going to be quite a bit like your multiple copy problem. How do you make sure that things are in sync across those systems? If you're thinking about something like a tape storage and a hard drive storage, it might be different ways of writing data. You might have different writing schedules. Yeah, it's more complexity there. Fixed monitoring. So again, we're monitoring things over time. So we have our fixed information, and then we have a process that goes and checks that our files generate that same fixed information over and over again. So we can do things like store stuff in bags and have like a constant bag checker. We can have some sort of repository software that's automatically checking this stuff. We can have a built-in integrity checker from the storage system. Lots of ways to do that. Challenge here, how often do you want to be running that fixity? This is a process. This is ongoing involvement. How often do you want to be checking in on it? And then how do you know that, sometimes files change and there is a good reason. Sometimes you want to replace a file, or you wanted to deaccession a file and you deleted something. How are you keeping track of that? Geographic redundancy. How are we going to do that? Well, maybe we partner with another organization and we hold copies for each other. That's one way. A very cheap way to do this, or a very common way, is to go to a cloud vendor and say like, hey, you have a center on the West Coast. Can I use that? And can I put a copy of my data over there? Yeah, that's possible. Problem here is that as soon as you start working with facilities that you don't control, you have to trust that other facility, and you have to have that kind of relationship with them to know that they're actually holding your data correctly. Security controls. Whether it is on purpose, malicious, or accidental, we do want to have control over what changes people make to the collections and storage. So how do we do that? Well, number one, don't give write access to the deep system, or strictly control that write access. Number two, have an auditing process by which no single person can do things like deleting a file or editing a file. Problems here: how do you audit that staff list over time? How do you make sure that the right people are allowed to give approval? And finally, budget. Well, this one's just hard. You need money. How do you make sure you have money? Well, you can go as cheap as you can when it comes to storage. You can try to reduce your complexity so you don't have to pay as much for staff and things like that. You can just build up a huge war chest to pay for it over time. But this is going to be one of the long-term struggles, is to think about how much our collections are costing us. In particular, because as people collect materials, we will have to continue to build more storage. Storage is not just a one-time cost, it's something we have to continually invest in. All right, so lots of issues, lots of things that we want to protect against. That's not just putting a file onto a storage device and calling it a day. You could imagine building out a system of all these procedures and doing things correctly and things like that, but a lot of these are so automated and so complicated that this is a place where a computer is probably going to be more effective than trying to do everything manually. And you see a lot of systems, they use some sort of software to manage their storage. So some examples here, we have the Archivematica storage service. So this is a system by which you process things in Archivematica, and then this controls the storage devices that you have. And it allows you to work with local storage. It allows you to hook up to cloud storage. As soon as something goes through Archivematica, it will spit out a copy to multiple storage systems. So hooray, you're doing some of that diversity in terms of geography, in terms of media. There's a fixity monitoring service that you could enable. Great, here's an example of a thing to manage your storage with. Preservica. This is another piece of software that people use in part to manage their storage. And again, this has ways to write to cloud storage, local storage. It has automated fixity checking. It has hierarchical storage management. It has different ways to manage these very big, complex issues by putting into place software that allows you to run these processes. Similarly, another open source option, DSpace. As you look through there, it has ways to be interacting with cloud storage, local storage. It has automated fixity checking. It has some of these things built in, user policies, security policies, things like that. And these are not the most exciting features. It's not the sort of thing that people love to hear about and get very interested in. But honestly, this is the greatest value of any repository software that you might buy, is that it helps you just not have to deal with the day-to-day humdrum of coordinating all these issues across multiple storage systems. That now you turn it into an interface that you can manage, and you can set policies, and you can move things around without having to know the complexities of any specific storage system. All right, so we're going to talk about more about software repositories next week, but let's talk a little bit more about the functions that they might provide right now. So one of those functions is managing storage hierarchy. So from OAS, it says this function positions the contents of apes on appropriate media based on policies, stats, or directions. This is the kind of thing where you can start mixing together your storage systems, that you want your software to be able to work on the types of media that you have. And so you might have different requirements for different kinds of files that you have. So for some, you might want that media to be immediately available all the time. If you're thinking about service files or very small files, images that are being served to the web, or things like that. You want that to be online. Another way that people talk about this is hot storage. So that could be, one way, keeping a USB hard drive connected, putting something on Amazon S3, their faster storage service, things like that. You could have nearline storage. So this is not immediately accessible when you call for that file, but it gets to you relatively quickly. So thinking about things like keeping something offline but disconnected, so like a tape on a shelf or a USB hard drive that's disconnected. Or Amazon S3 has an infrequent access tier that's like, okay, it's not going to be as fast, but we're not going to charge you as much money for this storage. And then there's offline or cold storage. So this is potentially a long delay in retrieving that data, but the trade-off here is that they will charge you less money for that. You're not keeping this thing running all the time. You're not paying that electrical bill. You're not needing to keep as many things in flight. So it's cheaper. So something like putting your tapes into a collection vault or into offsite storage, or putting your USB hard drives there, if that's what you're doing. Using something like Amazon S3 Deep Glacier, which they will actually charge you money for pulling a file out, but they also only charge you, I believe, 1/20th of the storage costs of Amazon S3. So there's a major cost trade-off that they're giving you there. Now, for different types of files, as I mentioned, you might want different types of storage. So you might want that very offline cold storage for your preservation files that only get used once in a blue moon. So why do you want them, to be immediately accessible? You can deal with a little bit of a delay there. And part of that is that in OAS, when we talk about the files that we store in collection storage, OAS says that those files are packaged together logically or physically. So that means that just because you say some files belong together does not mean that you have to store them in the same way. So one strategy that you could do, you could store them all the same way. It could be simpler. The problem that you run into is that you have to pay for the same cost of storage for all those objects. And you have to basically decide what is the cheapest level of storage that meets all of my needs for everything, for the most accessible and the least accessible. So you don't see this for large video collections. This is probably too expensive to pull it off, but for like a digitized image collection, yeah, if it's small enough, you might just dump it all onto Amazon S3 and be like, that's good. I want hot storage. It's fine. I can afford it. And that's great. On the other hand, for a large AV package or AV collection, you might want to engage in more complex management because that allows you to cost optimize. You could say, put my service files on the hottest, fastest, most expensive stuff because they're going to be demanded all the time, all over the internet. But the preservation files, tape system. Put it on like very slow, not that accessible, kind of annoying to deal with, but at the same time, reliable enough that we know our files are okay. We can check it as we need to check it. And we're spending a far, far lower amount of money than we are for that S3 storage. All right, so you have to manage those storage hierarchies. Part of that is that error checking process that's leading into there. We've talked about how error checking is supposed to be finding problems in your storage, finding files that have broken over time or that have gone missing or that are not in sync between copies. I will point out, as much as I emphasize this is not something that everybody does. And you will run into lots of organizations that you might be the first person that starts talking about fixed checking or backup integrity or data integrity or things like that. So this is an 8-year-old survey at this point, but back in 2013, the National Digital Stewardship Association did a survey on fixity, and over a third of people were not checking fixity. So it's a core practice, but it is something that is not as widespread as it should be. Just to remind ourselves, what is fixity? Any information that allows you to determine that a file has not changed. It could be file names, file sizes, checksums, file dates, things like that. And the reason why we want to be considering this is that we know we need to be doing it over time, but part of running Fixity is reading the files. Part of running Fixity is actually accessing files from our storage system. And well, as an anecdote, the Library of Congress, their National Audio Video Conservation Center, they actually take a full year to check the fixity of every single file in their system. So they have something like 20 petabytes of data. And so the day that they finish reading the 20th petabyte and calculating checksums on that 20th petabyte, they are starting again on the first petabyte for the next year's run. So these things do take time to run. It's part of the reason why you might not see people checking fixity all the time. It takes money because it does take computing power to do this. So as much as I say, checking fixity is a core practice and it's something that everybody should be doing, checking checksums is expensive. And you can absolutely make arguments to say, what is the correct amount of checksums to be checking? Because it's taking time and energy and money to do this. And maybe there's other types of fixity information that I could be using. All right, so yeah, I'm always a proponent of checking other types of fixity information. But how do we do that? So we can do things like build a fixity checking process ourselves. As I mentioned before, you could store things as bags and then validate your bags over time. You could write your own script. So you could check your fixity information if you have it stored in a non-bag-like way. You could buy a system that does this. So Archivum, Preservica, Libnova, Rosetta, all of these different digital repository places, they do fixity. That's just a button that you push and it's like, great, I will check that. Or you could build a system. You could do something like the Archivematica storage service or Fedora, where these are things that it takes more configuration, more investment of staff time to set this up. But again, a service that you run and not as much of a DIY solution as bag checking or script writing. So all of these things are good ideas. The end goal, though, is that they are running in the background and then they're reporting out to you and saying, hey, things are okay, or, oh, I found a problem, here's the file that's broken, what do you want to do next? Do you want to replace it? Do you want to act on it in some way? All right, so that brings us through these different functions that we have. The final question that we have is money.